Hey everyone, how's it going? Thank you so much for tuning into this video. I am very excited to be sharing this with you because this video is the beginning of what I hope will turn into a new long series of videos that are all about working with technology and electronics in live music performance, building your own DIY sensor-based controllers and using microcontrollers and things like that, working with alternate notation methods and graphic scores and different ways of composing for electronic instruments, and all kinds of things like that. So I'm very, very excited. This is just the first video, and this first video is going to be a bit of an overview, and I'm going to answer some questions that I get all the time about my own personal practice and the technology that I perform with all the time. And we're going to take it from there. So what I would really love from all of you is to hear either in the comments below the video, or if you want to send me a direct message, that's great too. Any future topics that you'd like me to talk about, or any areas or that you want me to dig deeper in, or any questions that you may have. Okay, so time to jump into the topic for today. The number one question that I get asked the most is what the technology is that I'm using on my trumpet. So if you follow me on social media, chances are you have seen me post a video where I'm playing the trumpet and I have some crazy looking wires and technology contraption hardware thing stuck onto the bottom of my trumpet. And often a lot of the sounds that I make, even though I'm playing a trumpet, don't sound anything like a trumpet at all. So that device is called MIGSI, and MIGSI is an acronym, MIGSI, that stands for the Minimally Invasive Gesture Sensing Interface. And this is a device that I co-developed and built with my wonderful friend Ryan Gaston. And we started working on this project in 2014. And the first prototype of MIGSI was finished in 2015, about a year later. MIGSI is a sensor-based interface, which means that it uses a series of sensors to collect data from both myself and the trumpet as I'm playing the trumpet in real time. There are 3 different types of sensors in total and 7 independent streams of data that is collected in real time by MIGSI. There are pressure sensors, or FSRs, force sensitive resistors, on either side of the valve casing of the horn, and these detect independent front and back pressure of my left hand as I'm holding the trumpet. There is a 3-axis tilt sensor and accelerometer that is underneath the valve casing, which senses X, Y, and Z tilt as I'm holding the horn. And there are also optical sensors underneath each of the valves of the trumpet, and these detect continuous valve displacement, or in simpler terms, they can tell when the valves are up or down, or in some place in between. They can tell the motion of the valves. So I said there were 7 independent streams, but now that I'm actually doing the math in my head, it would be 8. 1, 2, 3 on the valves, 1, 2, 3 on the accelerometer, front and back on the pressure sensors on the hand guard, so 8 streams of data in total. So this data is collected wirelessly by MIGSI using an Arduino, and then that information is sent wirelessly over to a computer using a pair of XB radios. And the MIGSI app that I use, that I perform with, is built in Max MSP, and this is something that Ryan and I have been working on and iterating for many, many years. And it started off as a simple tiny little Max patch, and it has grown over the last 5 years into a very robust and in-depth software app that I can probably get into in a future video, and maybe I'll bring Ryan in so that we can talk about it together, because it's been this whole project has been a very collaborative endeavor between the two of us. But to get back to the basics of how MIGSI functions, the data that comes in from the horn, which is captured in real time, is called serial data. That is then sent over to the computer, and it is typically conditioned or scaled to be more usable numbers, more usable range of data. And then that information is routed either internally through the app to control modulation or processing on the input trumpet audio signal, or it is used to trigger or modulate or otherwise interact with a synthesis engine that is running inside of the MIGSI app. So it can process the external signal and sound of the trumpet, or the data can be used completely separate from the sound of the trumpet to create or generate or interact with the synthesis of entirely new sounds. Additionally, that data can be routed pretty much in any way you can imagine. There are OSC outs and control voltage outputs, so it can be sent to interact with a modular synth instead of a laptop. That is a lot of fun, and I would be happy to take you into the studio someday and show you how that setup works as well. You can also send the data out as OSC to interact with any other program that works, that receives OSC. So you can probably by this point imagine that the sky is kind of the limit when it comes to what you can interface these things with. So I'm going to talk a little bit about why I started to work on MIGSI in the first place and what some of my motivations were as a performer, specifically as a classically trained performer of an acoustic instrument, to start to bring technology and electronics into my work. As I said, I am a classically trained trumpet player. I had been working and starting to get more interested in working with pieces with technology by collaborating with other composers throughout my undergrad and my master's degree at college. And at the same time, I started to take some introductory programming classes in a language called Chuck. Now, at this point, I had no experience with engineering or programming or anything like that, but I found it really, really fascinating, and I started to read some articles and some journal publications around the topic of integrating technology and music. And I very quickly discovered an archive of articles from NIME, which is the New Interfaces for Musical Expression conference. This is an annual conference that is held every year in different cities around the world. And it is a very, very fascinating place for people like myself who are interested in learning more about what's going on in terms of new instrument design and really just what is happening at the intersection of art and sound and technology research. So I was reading a lot of these articles, which by the way are not behind a paywall, which is amazing. I can include the link to the archive below in case you're interested. And I found a few articles about different types of wind instruments and people who were adapting traditional instruments like saxophones and flutes and trumpets by adding sensors onto them. And I was completely blown away by the possibility of doing this in my own practice. So without really knowing what I was doing, I kind of just jumped into this journey and started designing what I imagined my ideal interface to be. Then I teamed up with Ryan, and we basically just put our heads together and figured out how to make it work. So the main things that I was really focused on when I was developing MIGSI were three main considerations. Coming from a more traditional background, I felt that it was important to maintain the acoustic sound and playability of the trumpet. So I wanted to make sure that whatever I was building wasn't going to somehow take away from the already wonderful sound of the trumpet and the playability of the instrument. I wanted to make sure, in the same vein, that whatever I was building and whatever I was attaching to my trumpet was easily removable. This was actually a really big deal because I have one trumpet that I play and bring with me everywhere. And I've formed over the last, couple of decades playing this horn, I've formed a very close attachment to this instrument, as I'm sure you can understand with your own instruments that you play. So I wanted to make sure that I wasn't having to drill holes or permanently attach things onto my trumpet, and I wanted to come up with some kind of more easily removable or semi-permanent solution. So that was another major design consideration. And the third was that I wanted to build something that would leverage expert technique on the instrument. Now, what I mean by that, this is really closely tied into the other points in terms of playability. But what I mean by this is that I had spent at this point in time many, many years studying and practicing and developing technique on the trumpet. And as much as I was fascinated by the idea of augmenting this and, building a deeper practice and opening up new avenues for exploration, I wasn't interested in completely starting from scratch and having to learn a brand new instrument. So I wanted to design something that would allow me to play the trumpet and use the technique that I already had and to augment it somehow. So to leverage that technique in a certain way to open up new doors and new sonic possibilities and worlds. Thank you so much for watching this video. I hope that you liked it and I hope that it was informative. If you have any questions, like I said at the beginning, or areas that you would like me to dive deeper into in a future video, please let me know, leave a comment or send me a message. I would absolutely love to hear from you. And thank you so much to all of my amazing patrons who are part of my Patreon family, who have been supporting me and my music and my art for the last 2 years. They are a huge part of how MIGSI has come to life and how other projects with MIGSI have been able to be made possible. So thank you so much to my patrons. You are all amazing. And if you are interested in checking out some of the behind the scenes and early release and exclusive stuff that my patrons get, you can hop on over to my Patreon page, which is patreon.com/Sarah Belle Reid. And maybe you'll find something you like over there. Anyway, thank you again so much, and I will see you next time. Bye.